Hello everyone, my name is Fang. Today I will give a brief introduction to our team project. Our team has four members: Kai Chen, Li Pingding, Mian Huang, and I. For this project, we mainly focus on New York apartment interest level prediction analysis. During the pandemic, many people began to work from home. Gradually, relocation became more and more common than before. The demands for renting an apartment increased largely. Typically, people start by searching for apartment information online, then they go on a field trip to those apartments that look quite good online. An apartment renting website can only provide limited data or pictures for website visitors on their first page. Actually, we can notice an interesting that some house renting websites like Airbnb or renthop.com, they always list some attractive apartments at the top of the searching list. So the web visitors are more likely to stay on their web and willing to try their services. The tenants may just leave the website with lower attractive housing information on the first web page, and they will choose another familiar apartment renting website. So in this case, the website may lose the tenants only because the competitor in the market lists the same apartment on their first page. So here comes our problem. For online renting websites like renthop.com, they have so many apartments waiting to be rented, but which apartment should be put on the very first page? How can they attract more customers? Okay, people interested in renting an apartment may be influenced by many factors like location, price, layout, the apartment's pictures, etc. And we will do in this project, and what we will do in this project is to determine whether an apartment is highly attractive for potential tenants according to the information the website will render to the web page. Making the apartment search smarter by using data to source rental listing by the apartment quality and providing an intelligent recommendation system would help the website provide better experience to the tenants, and the tenants may share the website with their friends after a great experience on the website. Okay, here is a quick insight for our project. The website we plan to serve is renthop.com, and we use the data source from the following link here. The renting area we focus on is New York City. Here are the features of our dataset. Like we can see in the picture here, we have so many features. For example, the bathrooms, the number of bedrooms, and the address of the apartment, the photos, and the price. Also here, the text variable is the interest level. The interest level variable has three categories: low, medium, and high. And this is a picture of distribution of target feature, the interest level. It's quite obvious that our dataset is an imbalanced dataset. Okay, let me show you the data exploration part of our project. Here is a picture of the relationship among number of clicking and number of bathrooms. Oh, sorry, number of bathrooms and interest level. This is a picture of the relationship between number of bathrooms and interest level. This is the relationship. This is the picture of the relationship among number of clicking, number of bedrooms, and interest level. This is the picture of the relationship between number of bedrooms and the interest level. This is a picture of the relationship between number of photos displayed on the website and the number of occurrences. This is a picture of the relationship between number of features and the number of occurrences. Okay, that's all for my part, and next my teammate Kaichi Chen will introduce the following part. Thank you for your listening. Bye.
Hi everyone, this is Kaiji Chen. I will talk about the methodology of our project. In total, we applied 6 supervised learning methods. They are gradient boosting classifier, random forest, supports vector machine, adaptive boosting, naive Bayes, and K-neighbor. Next, I will make a brief introduction to each method. First, let's take a look at the gradient boosting classifier. This method combines many weak learning models together and then creates a strong predictive model. It contains 3 main components: loss function, weak learner, and additive model. Let's talk about its advantages. It has lots of flexibility, can optimize on different loss functions, and provides several hyperparameter tuning options, which makes the function fits very flexible. And it's good at handling missing data. We don't need to do the imputation work. Then let's move to the second method, random forest. In this method, there exists a large number of individual decision trees, and each individual tree spits out a class prediction. The final result comes from the class with the most votes. Let's take a look at its pros. First of all, random forest performs well at handling large datasets, and it solves a problem of overfitting as output is based on majority voting or averaging. Because of the existence of many decision trees, this model is highly stable but also maintains diversity. Next, let me introduce our third model, support vector machine. It will find a hyperplane in an n-dimensional space that distinctly classifies the data points. So our objective is to find the best hyperplane, which maximizes the margin from both classes. This will provide reinforcement, so if new data points are added later, they can also be classified with more confidence. Its advantages are obvious. It works really well in a clear margin of separation, also effective in high dimension spaces, and it's good at saving memory because it is a subset of training points in the decision function, which is also called support vectors. Next, I will introduce the adaptive boosting method. The main idea of adaptive boosting is to maintain a distribution or set of weights over the training set. So initially, all weights are set equally, but on each round, the weights of incorrectly classified examples are increased so that the weak learner is forced to focus on the hard examples in the training set. In this model, it's easier to use with less need for taking parameters, unlike other algorithms like support vector machine, and it can be used to improve the accuracy of weak classifiers. Next, let's talk about naive Bayes. In this model, there is conditional independence between every pair of features. The main idea of categories naive Bayes algorithm is that The result is decided by each feature appearance probability. Last, let me introduce our sixth method, k-neighbors. We can see that each neighbor point has a right to vote on a query points category. Each neighbor has its own weights, and a large k-value would suppress the effect of noise that also makes the boundaries less distinct.
Hello everybody, I'm Li Ping. Today I'm going to do the code explanation. Let's start. First is the data cleanser and visualization. We list all the features and explore the relationship between them. Then we do the data visualization methods like histogram and box plotting. Then we produce new features using the following code. After that, we also do the feature processing because we need them to fit in our code, in our model. We use the methods like gradient boosting, classifier, define functions, prepare data, normalization, and adding interest level and visualization. We also make a prediction, tree model, visualization, and create classification report. We also use other methods like random forest support vector machine and other boosts to extract numerical features and label. So let's go to our living code. First, we create a class to display and explore data. We found there are 15 instances. First is bathroom number, bedroom number, and features, photos, price, and interest level. Among them, the interest level is our target. And we found the price has outliers. So with the 99 percentile as limit and exclude number above that, then we get the highest number of listing price is 6,000, and a majority of the listing price among the 2,000 to 4,000. And we also found the interest level. There are three classes. One is a low, second medium, and the third is high. We further explored the relationship between the key variables. We found majority of people love their low listing price, and these are the bathroom number. And we explore the relationship between the bathroom and number of clicking advertisement photo. We found that majority of people interest in the one bedroom, one bathroom. Here we go. It's really interesting because formerly we assume that people would love more bedroom and more bathroom, and so we decided to take a second to verify the relationship between the number of bedroom and interest level. We still get the same result, and we also want to explore the relationship between the listing price and interest level. We found people are more like the low listing price. And further, we explore the relationship between number of photos and the number of occurrences, which means if you have more photos, the people will be more interested to click the link and take a look. And also, the more features, more people will show interest. And there's 15 domain features, and also some new features will draw our attention. That's the reason we create a second class called the feature engines. We create features first, and then we also add the manager ID and the manager skills as features, because we believe manager ID and manager skills also play an important role for a successful rental transaction. Okay, so for the model selection, we gradient boosting classifier, we define the function and we prepare data and visualization and make prediction. We found the gradient boosting classifier is not good enough, so we choose other three, like random forest data boost and support vector machine. We use different methods to approach and we'll load the data sets, transfer the column to numerical features and extract numerical features and label, and also split the train and test data. And we got the accuracy in classification report and ROC. After doing the random forest data boost support vector machine, we got our conclusion and also generate the future work. It's our fourth part. Mia will give a detailed explanation. That's all for my work, for my code explanation. Thank you. Have a great day. Bye.
But before this, I got to discuss an interesting thing. That is, the data set we got from the resource is unbalanced. Why we should pay attention to this issue? Because it did influence our final results. Let me show you an example. First, let's look at how unbalanced it was. It is. We get 35,000 low interest level data, but only gets around 4,000 high interest level recordings. How it influenced the final result? Before we balance the data sets, the prediction process of high interest level is 0 to 7, but after we balance the data, it improved to 76%, but the overall accuracy didn't decrease much. Let me show you another example. We also did the comparison in support vector machine method. Before balance the data, the prediction process value of low interest level is 100%, but for the high and medium categories, they are 0. It is a overfitting scenario, I think. But after we did the balancing operation, the value of high interest level improved from 0 to 62%. We did all this comparison for 6 methods we used in this project, but I didn't want to talk everyone. Okay, let's go to the next part, which is our conclusion. Like we discussed before, the unbalanced data may lead to overfitting, like in the no matter key labels or like support vector machine method. And we also differentiate some key factors. There are price and bathroom and the number of bedroom. At the beginning of this project, we think the location may influence the customer's choice. With better location or better community, the apartments may be more attractive for the customer. But when we visualize the data like this scatter graph, the high interest level filled all the areas. So we think the location didn't influence the final results very much. And the last thing I want to talk about is the the overall prediction accuracy doesn't equal to the business value or the business or didn't too much business contribution. I mean, if let me give you example. If you are the business owner or the website owner, you would want to select and fill out all the high interest level apartment information and place them on your first page rather than hide them or uh, leave them at the following pages because they want to attract your customers at their first glance and keep them stay with your website, right? Because that's the way you make profit because you want your customers to stay with your products and pay the money for your products, right? So next, I want to talk about the results. We compared all the 6 methods and finally we think the gradient boosting classify method would be the best choice. No matter the dataset is unbalanced or balanced, it always gets the best results. And even for the high interest level category, they also get 76% prediction process for the category. Okay, in the future, we also think we can do something to improve our model, like identify the outliers. We think the outliers may be could be better data, which means we should drop this because the bad data or wrong data may influence our final model, right? And the next thing I think is we should also take the picture and language information to our consideration. Like we should fit this information, also fit this information to train our model, right? Imagine you are the visitors when you come to a website or like the like this. The first thing comes to your eyes would be the picture. If the picture looks good and apartments looks tidy and clean, you would like to pay more attention or time on this information and then go to the price and how many bedroom it has and bathroom, and then you will go to the language information like the features and the apartments managers information like this. The last thing I think we can also do is tuning the parameters. What we did in this project is just use the sklearn library and with its default variables value. We didn't change it often, like the decision tree depths or the key values of key neighbors classify method. If we can do the changes and compare all these models, I think we can also get a better results. Okay, next word. Thank you for listening.